This video is going to be working through some of the problems, the redox problems that you might find on the exam. And so just to start, I want to just quickly refresh your memory of how we actually write ions, or how ions are even formed. In that, remember, you have for oxygen, let's say you have 8 protons, you have 6 electrons, because protons always equal electrons, and so the overall charge is 0. And the reason is, remember, protons have a positive charge, so you have a +8. Electrons have a negative charge. Because you have 8 of them, you have 8 negatives, and those add up to being a 0 charge. However, in some cases, like in oxygen, you have, for oxygen, you have 6 valence electrons. In that case, remember, it wants to have 8, so very likely it's going to want to gain 2 electrons. So it's going to try to gain an electron for this spot and for this spot, and that makes the valence electron shall be 8. So in that case, you've now gained 2 electrons. That means instead of having 8, you have 10, and that means you now have 10 negative charges. So oxygen now has an overall of a -2 charge, and we would write that as O - 2. Okay, so just as a refresher of where we get these charges from, remember, it means that this oxygen gained 2 electrons to become more negative. So in this, in what we've been doing, we have been looking at different types of atoms and needing to decide whether or not they gain or lose electrons. And we've been calling the loss of electrons that it's been oxidized, and the gaining of electrons that an atom has been reduced. And the way that we remember it by oil rig. So oil rig represents oxidation is losing electrons, and reduction is gaining electrons. So when you look at the first example, you see that chlorine has a -1 charge, and then it goes to being a 0 charge. So it looks like it's becoming more positive. Remember, to become more positive, it must have lost that negative electron to become more positive. So in this case, this is an atom that was reduced, that was oxidized. That means it lost its electrons to become more positive. In this case of sodium, you have a +1 charge, and sodium now has a 0 charge. So from +1 to 0, it looks like it's gotten more negative. That must have been because it gained that negative electron, and gaining electrons means that it was reduced. Okay? For this one, we have a -2 charge going to a -1 charge. That means it becomes less negative, more positive, and the reason it becomes less negative is because it lost that negative electron, and so this one is oxidized. For magnesium, you start off with a 0 charge. Remember, I can tell if there's no charge up here, it's 0, and then goes to a +2 charge. In this case, it's becoming more positive. The reason it's more positive is because it's lost electrons. Again, this one is oxidized. And for this one, you have a +2 charge going to a +4 charge. Again, it's becoming more positive, and in that case, it must be because it lost electrons. Again, it is oxidized. So it's just a good way to review and determine how to see whether or not you've gained or lost electrons. Now, in these scenarios, you have what we call the net redox reaction. Okay, and so what you're going to be doing to determine which element is oxidized and which one is reduced is literally take the element and compare it to what it was before to what it was after. So here the tin, Sn, has a 0 charge and becomes a +4 charge. So in that case, I know that it's becoming more positive because it lost electrons. That's what allowed it to become more positive. Here I have a +4 charge, and now it's a 0 charge. It seems to become more negative, and the reason it did is because it gained those negative electrons, and here it gained electrons. So I'll go back to my oil rig. So remember, if you lost electrons, it's the oil. Oxidation is losing. The element that lost was oxidized was Sn. Okay? So Sn was oxidized. This one was the one that was oxidized. And I know this because it lost the electrons to get the +4 charge. Then, obviously, if Sn is oxidized, it is the Pb +4 that's been reduced. And the reason I know that is that it starts as a +4 charge and goes to a 0 charge. Now for oxidizing agent or reducing agent, it's actually very simple. It's what was it that gained those lost electrons, or in other words, it's just the opposite of what was oxidized. The oxidized agent in this one is Pb +4. So you can just always write the opposite one because it's the one that gained the electrons from the tin. And the reducing agent is just the opposite one of what was reduced. In this case, it is the tin, Sn, because it was the one that gave those electrons to the lead. So let's now bring it together in an equation. So first of all, you have these two reactants. You want to determine whether or not these reactants actually will react. And I look at my activity series and see that yes, magnesium does in fact is more reactive than copper. So remember, the magnesium is going to be knocking off that copper and replacing it so that it actually combines with the nitrate. And just to remember, this is a cation, and this is a cation, and this is an anion. And remember, cations want to combine with anions due to that positive-negative charge. It will never want to combine with another cation. So as a result, we have now Mg NO3 2. Now, how do I know to write the 2? Just remember, magnesium has a +2 charge. Nitrate has a -1 charge. We need to get these to be neutral, so I need to have 2 nitrates to get that 0 charge. And as the magnesium takes that nitrate and they are attracted to each other, that copper is knocked off and is by itself. So, first thing we also need to remember, next thing we need to remember is that when copper has bonded or been attracted to the nitrate, remember it's given its electrons to the nitrate. And so for that reason, I know that copper has a +2 charge because in order to have even bonded, it actually gave those 2 electrons to the nitrate. And magnesium, which is by itself, it hasn't lost or gained any electrons because there's nothing it's combined with to give or lose the electrons. This one has a 0 charge. This magnesium now has bonded with the nitrate. That means it has had an opportunity to give those electrons to the nitrate. And I look at the periodic table and I can tell that magnesium will always lose 2 electrons. The copper is by itself, and so it has gained the electrons from that magnesium. So even though it was a +2 charge, it gained 2 electrons to now have a 0 charge. So this is going to be really key for us in determining which one is going to be the oxidation half reaction and the reduction half reaction. So here above I wrote the complete chemical equation. Be sure not to include these positive or negative signs underneath. And remember, oxidation means that the element is losing electrons. So in this case, if it's losing electrons, it becomes more positive. So magnesium starts as a 0 and goes to a +2 charge. That looks like it's becoming more positive. So magnesium is the one that oxidized, and I simply write Mg with an arrow, and Mg plus 2, because that's what it became, and separated. Remember, this plus means that it has separated itself with 2 electrons. Okay? The other one has to be the one that's reduced. So in this case, copper, remember, has a plus 2 charge. So it becomes 0 charge. What that means is that it's gotten more negative. The way it got more negative is that it added 2 electrons. So here's how I can tell. For the plus on the reactant side, that means that it is added. The plus on the reactant side means that it has separated. So in this case, we have now copper having a 0 charge. So the net redox reaction is that you have magnesium combined, or magnesium giving its electrons. So we start off with magnesium and copper with an ion with a plus 2 charge. So I essentially write what I see in my reactant side on both sides, but I ignore the 2E. And then that magnesium becomes to have a plus 2 charge, where the copper has a neutral charge. So I'm essentially rewriting this reactant side and separating it from the 2 electrons. So in that case, if I know that magnesium was oxidized, what was the oxidizing agent? It's always the opposite one. It was the copper, the plus 2. What was the reducing agent? Okay, I know that it's always the opposite of what was reduced. In this case, it's magnesium. We're going to try one more. And in this case, what you're going to be doing is having lead 4 combined with copper sulfate. So in this case, just remember, lead 4 means that it has the ability of having a plus 4 charge. But because it's by itself, we know that it hasn't had a chance to give its electrons away because there's nothing to give its electrons to. So we just write Pb. And we said that it's combining with copper 2 sulfate. So copper is Su. Remember, it has a plus 2 charge. Sulfate is SO4. I know that has a minus 2 charge. So a plus 2 and a minus 2 shows that we just need to have one of each to get to be that neutral. So now, how are these going to combine? Is lead more reactive than copper? And if you look at your activity series, you see that it is. So in this case, the lead will take the sulfate to be PbSO4, and the copper is going to be knocked off. So remember, when you get those ionic compounds, you want to make sure that you check their charges. So in this case, sulfur has a minus 2 charge, Pb has a plus 4. I need to have 2 sulfurs to take care of that. So let's just refresh. Remember, lead is by itself, so it has that 0 charge. Copper has combined with another ion, so it has the plus 2 charge. The lead now has combined over here. It has its plus 4 charge, and copper now by itself has a 0 charge. So which one was oxidized? So let's take a look. Over here we have lead that started as a 0 charge and became more positive. The reason it did is it lost those negative electrons. And that, remember, is oxidation. So I write Pb with Pb plus 4, and it's 4 electrons that were separated. Okay? For the reduction reaction, remember I have here the copper. Copper has a plus 2 charge. In order to get that 0 charge, it must have gained 2 electrons. So I write 2 electrons here, and write Cu. Okay, so now we can write the net redox reaction. In this case, I'm going to actually include the dot diagram, which I forgot to do before. So keep in mind, lead seems to have 4 electrons that it wants to give away. Copper has lost its 2. And now copper has the ability to gain those 2 electrons, so it gained 2 electrons from the lead. And the lead has lost all of its electrons, so we just say a plus 4 charge. Now, copper could only take 2 electrons because remember it has that +2 charge. It has the ability to only gain or lose 2. But lead wants to give 2 away. So what I'm going to do is I'm going to have 2 coppers here so that we have 2 coppers that each can take 2 electrons. And then I just need to place a 2 over here, place a 2 over here,